We all know what this is. It's an aluminum can. But do you know how it's made, transported, commercialized, and reused? I'm Alicia Mather, and today on the beautiful Shadyside Academy campus, we are going to be discussing the life cycle of an aluminum can.
Aluminum is the second most abundant element on Earth's crust, second to silicon. It's lightweight, easy to mold and recycle, it resists corrosion, and stands up to repeated use.
Now I'm going to be talking about the mining and extraction process for aluminum. To begin, to make the aluminum ore, known as bauxite, it must first be mined. The main sources of bauxite are in Australia, South America, and Africa, but other countries including China, Jamaica, India, and the United States also have large amounts of the ore. Bauxite is never found in a metallic form, but it is found in rocks like feldspar, mica, granite, clay, and gemstones. Only earth with an aluminum oxide content of 30% or more is considered economically practical, and the greatest quantity of commercially exploited bauxite lies at or near the Earth's surface. Bauxite is mined in open pits. It is blasted loose and dug up with power shovels or drag lines. Afterwards, the ore is transported by truck, rail, or conveyor belt to a processing plant, which should hopefully be near the mining plant to help avoid costly transportation and less fuel being released into the air.
Bauxite ore is transformed into aluminum in a two-step process known as primary processing. The Bayer process is the process of refining bauxite to produce alumina. Bauxite contains only 30 to 60% aluminum oxide, while the rest is a mixture of silica, various iron oxides, and titanium dioxide. The aluminum oxide must be purified before it can be refined to aluminum metal. In the second step, the alumina is smelted into pure aluminum metal through the Hall-Héroult process, which is the major industrial process for smelting aluminum. It involves dissolving aluminum oxide in molten cryolite and electrolyzing the molten salt bath. The process happens between 940 and 980 degrees Celsius and produces 99.5 to 99.8% pure aluminum. Approximately 4 tons of high-grade bauxite yield 1 ton of aluminum.
The sheet is about 5 feet wide and as thin as construction paper. A roll like this is long enough to make 750,000 drink cans. The sheet feeds into a press that punches out round pieces that'll be formed into cans. The punch press actually performs 2 operations. It punches at a disc 5.5 inches in diameter, then bends it into a cup. What's left of the sheet gets compacted and sent back to the aluminum factory, where it's recycled into new rolls. The cup goes into a machine called the draw and iron body maker. A tool draws out the aluminum, forming the body of the can. The tool is lubricated so it won't tear the aluminum while stretching it. The lubricant also acts as a coolant because the aluminum heats up as it's being worked. Once the body is formed, a trimmer cleans and straightens the edge. Now the cans move along upside down on the conveyor belt over to the washer. The washer performs a 6-stage cleaning. The first 2 washes are in hydrofluoric acid at 140 degrees. The last 4 washes are in deionized water, neutral water with no pH, also at 140 degrees. The cans come out of the washer and go under a hot air dryer. They're now shiny because the hydrofluoric acid wash removed a thin surface layer of aluminum. Next, a roller passes over the cans, coating the bottom rims with varnish. This varnish coating allows the cans to slide easily on the conveyor belts and in the vending machines. It shows up as a blue ring under an ultraviolet light.
Because aluminum cans are so light, they are easy to ship and easy to stack. Aluminum cans do not weigh much, so many can be transported at once. Less trucks equals less fuel. The overall transportation carbon emissions are pretty limited due to the logistics of supply chains. The transportation of aluminum is more efficient in packaging and cooling, which means less energy is necessary and there's a smaller carbon footprint than either plastic or glass.
The biggest use of aluminum in our world is for the aluminum can, and approximately 180 billion cans of aluminum are produced annually worldwide. There are 6 advantages to using the aluminum can. Number 1, it's lightweight, which makes shipping more efficient. Number 2, it's cheaper to produce, which reduces the overall cost of production. Number 3, the use of easy open aluminum ends does not require the use of a can opener. Number 4, it has a clean appearance. Number 5, aluminum does not rust. And number 6, it uses less space in the refrigeration process compared to plastic or glass bottles, which reduces the amount of GHG emissions released.
In 1966, the Adolph Coors Company developed a technology for manufacturing new aluminum cans out of used cans. In 1967, both Coca-Cola and Pepsi converted to aluminum cans, establishing the aluminum can as the container of choice for the beverage industry.
Hi, so can you introduce yourself?
My name is George Miller. I am the foreman of Fitzsimmons Metal.
Nice. So, do you have like an estimate of how much aluminum you receive here?
In a good month, probably 10,000 pounds.
And where do you send these aluminum blocks to?
They go sometimes to Gottlieb, all over the place. All depends who's paying the right amount of money, I guess. That's the way my boss looks at it.
Yeah. So where are the best places to collect used aluminum beverage cans for recycling?
Probably a bar.
And
or a restaurant. One of the two.
Oh, yeah. And how should people best prepare their cans to be recycled?
Well, you want to rinse them out so it doesn't attract the bees and the fruit flies. Because in the summertime it does attract the bees and the fruit flies severely.
Yeah. And you did mention some people stuff
And
things in
people,
their cans.
some people hide metal in them so they can get more weight and stuff like that. But that's what the piece of the magnet on the end of the machine's for, so they kick it out.
Yeah. And how can a person best tell if a beverage can is aluminum?
I don't know if there's any cans that ain't aluminum anymore. I don't think they make any steel cans. Unless, there's soup cans and stuff like that.
Yeah. And can you explain, I guess, the process of when you receive the cans versus when you go all the way to the smashed aluminum blocks?
Well, we buy them off the customer, tear the bags open, dump them in the conveyor, and smash them down into the conveyor and make the block out of them.
Okay.
When it gets certain height or certain width, we take it out and weigh it up, and that's it.
Okay. Great. Thank you.
No problem.
Disposal. Aluminum requires 96% less energy to make from recycled cans than it does to process from bauxite. Step 1. Collection of scrap aluminum. Scrap aluminum and steel are collected together and are transported to the treatment plant. Step 2. Sorting. The cans are taken to a materials recoverings facility where they are cleaned, sorted into different metal streams, and later compressed into bales. Step 3. Shredding. The bales are later transported to a processing plant. The shredder then cuts the cans into tiny pieces. This makes it easier for the metal to melt quickly in the furnace. Step 4. Passing of a magnet. The shredded cans are passed beneath a powerful magnet. Since steel is magnetic, it is easy to separate it from aluminum once it is passed under a magnet. Step 5. Decoding. The aluminum shreds are then taken by the conveyor system into a specialized decoder. This is where all the decorations are detached from the shredded pieces. The decoder then blows very hot air through the tiny pieces of shreds and the coatings vaporize. The hot gases are then removed and cleaned. Step 6. The decoded shreds are then fed into the furnace. The furnace is heated up to 7,000 degrees Celsius. During this process of melting, chemicals are added into the molten aluminum to make it have the correct composition. All the impurities will then float to the top surface of the hot aluminum. This forms a layer called dross. The dross is then removed using a specialized scraping tool. Step 7. The holding furnace. This is where the aluminum waits to be turned into ingots. Step 8. Transportation of the ingots. The ingots are then loaded onto a waiting truck to be transferred and dispatched to the rolling mill. The ingots are then rolled out, making thin sheets of aluminum. The sheets of metal are then collected and used by the packaging factories to make drink cans, foils, and other useful products. Then the process begins once again. In the span of as little as 6 weeks, the recycled aluminum products are sent back to the shelves in the shops and in supermarkets ready for usage.
Every minute, 120,000 aluminum cans are recycled in America.
But at the same time, in every 3-month period, enough aluminum cans are thrown away to rebuild the entire American commercial fleet.
Aluminum cans can take anywhere from 80 to 200 years to decompose in a landfill. Trash is buried in the most contained way possible. Trash is delivered by trucks to what is called the open cell. After being delivered, the trash is driven over by heavy machines called compactors. Some of the trash is recovered to be recycled, but the vast majority is thrown into a landfill. The compactors squeeze out as much air as possible. After the cell is full, it is covered permanently with a layer of material, usually dirt. Modern landfills are lined with material to keep contaminants inside the landfill from leaking out. They also have landfill gas collectors to capture most of the methane that the materials inside of the landfill produce. It can take 200 to 500 years for an aluminum can to decompose in the ocean.
Americans alone send about $1 million worth of aluminum to landfills annually. This aluminum could be recycled and reused, which is more economically friendly. The process of recycling is slightly more expensive than landfills, but because recycled materials can be reused after being recycled, recycling is ultimately cheaper.
What can we do to use less aluminum cans? We can use reusable bottles. Recycling is easy enough because it is much cheaper in the long run, much less pollution is added to the air, less extraction leads to much less energy used, less aluminum ends up in the habitats, so less organisms are affected, and 20 recycled cans can be made with the same energy as one extracted can.
Thanks for tuning in to this week's episode of 10 Minutes. And remember to think twice before chucking this aluminum can into the trash.